So yeah, just to give a quick introduction, I'm going to be talking about why AI-first architecture could be sort of our big engineering crisis. I think everyone is vibe coding at the moment. And what does that mean for our infrastructure going forward, and especially our Python ecosystem, right? And most of my background has been in AI engineering, as said, and I've been a data scientist, and primarily very pre-GPT time. So really used libraries from scratch and really used all of this to build models. But now everyone is prompting. So then what exactly happens going forward, right? So that's what my talk is going to be about. I'm going to give a few situations and sort of try to understand what you folks feel, and then also going to give a few scenarios of people or companies that have already integrated AI at every stage, and what does that look like for them, right? Where are they running into issues, and maybe you're running into the same issues you don't know yet, or maybe you will in the future, right? So yeah, that's what the talk is about, and I gave a bit of a background about me, but mostly I've worked with AI engineering and obviously worked in the Python ecosystem as well. I help out at Python Software Foundation, and most of my roles have now been very community related. Okay, I'm going to start with a question to capture your, I guess, attention. So over here, let us say there's a company that needs to build a sophisticated booking system for a cruise line that handles multiple ships, cabin types, customer profiles, and payment processing, right? Maybe you as an engineer or a product manager or a project manager, what do you think best represents how you would handle this in a traditional software architectures? Would you actually hire a team of 30 developers to simultaneously code all features, then integrate it in the end? Would you start coding immediately based on a rough outline and adjust this as you get customer feedback? Will you actually follow a sequential process of requirement gathering, architectural design, component design, implement testing, and deployment? Or would you actually purchase AI code generator and have it build the entire system for you? So what do you think you would choose for this particular scenario? And again, I don't know what you're answering, so don't worry, no judgments here. The idea is to just get a grasp of what folks feel is really happening in the background, or what would they do in such a situation, and try and explain where, AI is plugged in, and possibly also explain where I see failures already happening and where it might happen in the future. So yeah, that's amazing. A lot of folks already say they're going to follow a sequential process of requirement gathering. So I put up this very, I guess, messy flowchart here, but what it basically goes through is a traditional software engineering architecture, right? You start off by doing requirement gathering, where you identify, you understand user requirements, then system requirements, and then feasibility studies, and then you would ideally move on to architecture design, right? High-level system design, component identification, technology stack selection, etc. And then obviously come up with a detailed design on component-level design, algorithm design, and then data structure design. So all of that is also handled. And towards the end, you would always have an implementation or coding, and then testing, and then actually deployment, and then maintenance and evolution. So this is something that traditionally all software architectures will follow in one way or the other. Even if you miss out on certain parts or replace certain parts, this is what it looks like, right? And now coming towards where you think AI will be used in this pipeline, right? And especially a lot of libraries will be used in this pipeline or replaced in this pipeline. So let us look at this another question here. Your product manager wants to add a recommendation engine to your e-commerce platform that suggests products based on browsing history, purchase patterns, and seasonal trends. Would you use the traditional waterfall approach, but with AI tools to accelerate coding? Would you actually put an AI system at the center of the cyclic process that I put it over there, the flowchart where it generates? Would you replace all human developers with AI and eliminate the phase entirely? Would you generate the entire code base at once using AI and then deploy it without testing? So which one would you use? Yeah. So again, feel free to put any answers in. I have literally no clue who's adding what. And the idea behind it is just to understand where you're coming from and what you choose. Yeah, awesome. So again, like a lot of us might be coming from traditional backgrounds or have been a software engineer for a long time, and we would end up using the first approach, which is really good, right? Like this is exactly what we want. And so now let us look at how AI-first software engineering architecture really looks like. So let's start from the top, right? So let's look at requirements co-creation, right? That is where you'll ideally use AI, maybe a product manager does, to collaboratively generate requirements, and AI sort of validates those requirements for consistency, completeness, and maybe suggests like or identifies potential issues. And then you can do like architectural exploration as well to an extent. You can ask like AI, okay, can you generate multiple architecture options? Can you evaluate and refine them? And then you can, what we do already, vibe coding, right? Like AI generates code for certain parts of the architectural decisions, and we look at what the code it generated, and sometimes it's extremely bad, and sometimes it's good enough to be deployed. So yeah, we go and improve the codes it generated. And then when you look towards the end of the pipeline here, it is like continuous verification, where you maybe AI can be used for creating tests and identifying edge cases. And AI can also be used to analyze code for potential issues. And then adaptive deployment, maybe AI comes out with your deployment configurations, or AI monitors the performance and suggests like optimizations. And eventually you want it to do like some kind of proactive evolution, right? Like where it analyzes the system for improvement opportunities. So this is something that maybe ideally would happen in a very ideal world where AI, helps out with every step and does it perfectly, right? But what really happens out there, right? I have, unfortunately, another question as well. I hope I haven't bored you. And I know I've been giving a lot of diagrams, so the hope is that you can see this and think about it. So let us say a major retailer sort of adopted a AI-first architecture for the inventory system. 3 months after deployment, they discover the system occasionally processes returns incorrectly, causing customer complaints and inventory discrepancies. So not the same domain, but I worked with a company or consulted a company that has deployed something and then later on found out that there were issues. So where do you think the issue could have come with? Or where do you think the failure likely originated? Did it originate at the AI requirements, where there was a co-creation of maybe AI misunderstood the business rules? Was it in implementation, collaboration, like where AI generated code with like subtle logical errors? Or was it in continuous verification, where AI generated tests which failed to catch like edge cases? Or was it at a proactive evolution, where AI made like unauthorized changes to the system? Again, the idea here is like no perfect answers, but something to think about as to what happens when these things actually get deployed. Awesome. So yeah, most folks here are absolutely right. So AI-generated tests actually fail to catch edge cases. So this is something that I've actually seen, is that AI tends to hallucinate, or most LLMs tend to hallucinate, and that actually happens in the edge cases. It doesn't happen in the test set you generate, but it will happen in the test set that it hasn't understood, or like cases that it hasn't seen already in its training data, right? And now comes, like, that was one point where you understood that there were edge case problems, but when you look at the architecture as a whole, and again, this is something that I have generated and like sort of gone through in my head, I see like various points where failure to sort of occur through the pipeline, right? The first is hallucination failures, right? With the requirement co-creation. So let us say that means maybe AI is inventing non-existing requirements. And then let us say, like, at architectural exploration, there's pattern misapplication. Maybe AI is suggesting inappropriate architectural patterns, or AI is generating code with subtle logical flaws, and then AI is failing to test critical edge cases, which is exactly what happened with this company. And AI is making inefficient deployment decisions, and AI is suggesting sort of these changes which is not good, or like introducing changes that doesn't really help. So another situation that I've actually found happen is, like, let us say this particular case, right? This particular company used actually AI to build like an authentication system for their new healthcare application. And during like a security audit, a serious vulnerability was discovered, which basically exposed patient code, right? So what do you think happened, right? A, did it deliberately create malicious backdoors inserted by AI? Or B, was it outdated security practices copied from like sort of the training data? C, was it a complete absence of any authentication checks? Or D, was it encryption algorithms that are too strong and slow down the system? I know this is a bit of a difficult question, but yeah. So again, like no right answers, no wrong answers. The point here is to understand that, oh, this happened to a company, and then like, what did they do? Where did they find the issue that came out with? Exactly. So AI actually generated, was looking at outdated practices, and this happens often, right? Because you realize that these LLMs, like if you take like if your, I guess, architecture or your model that you're using for deployment is using GPT-4, means the training data for GPT-4 is what it's looking back at, right? And you are just doing an API call, and you don't know that GPT-4 actually can or cannot look at newer data. So at the same time, you end up like using parts of the code which are pretty outdated. This includes security vulnerabilities, which people don't think about when they are like vibe coding and putting things out there very quickly, right? So this is a really nice company's like, I would say, use case around where they found AI failure points to come in. And this is taken from Gargali's article on AI engineering in the real world. He took it out like a couple months ago. And so there's this person called Ross McNain from Wordsmith, who identified that the biggest challenge for developers transitioning to AI work was the fact that AI actually produces a lot of varying results from the same input, right? And that is something that is going to keep happening with vibe coding, right? Like every time you ask it to generate like even a website, it's always generating something different. And that is something they also found out. And the way that they approached it was, oh, can you have good evaluation frameworks to sort of assess the AI output quality? Can you actually have like domain-specific quality metrics, right? Because if you have like general or generic quality metrics, you know the AI will tend to pass that anyway. And you need to build systems that improve these feedback loops as like seen by the chatbot implementation, or like creating these approved answers for knowledge bases when deterministic responses are required. And so with this case, they clearly had an issue with pattern misapplication, sort of AI suggesting inappropriate architectural patterns. And there's another interesting case study that Gargali pointed out, which was a fact about this like Data Solutions International that sort of showcased how AI vendors oftentimes propose unnecessarily complex architectures. I don't know if your companies have done that already, tried outsourcing some form of AI to a third-party company. And what happens oftentimes is that they will take 6 to 9 months to do something similar, and it actually costs way more than actually building the infrastructure in-house. And I've actually talked to a lot of companies that are jumping on the wagon now. They're like, oh, we need to do generative AI, because if we don't do it, we are not going to get like our next round of funding, or maybe we won't be labeled as an AI-first company. But what does that mean? Like, does it mean that you couldn't do the same thing with a few Python libraries in-house, right? So those are the questions that you should be asking when a company jumps into, oh, AI-first architecture or implementing these generative AI application. Yeah. I have another question here as I go forward. And again, it's just to get your attention, so don't worry. The idea behind is to just come up with good situations and scenarios which make sense. So let us say your team is building an AI application that needs to perform various types of tasks, right? Like code generation, summarization of legal documents, and real-time content generation for user interface. You're debating whether to standardize on a single AI model or use specialized multiple models. I think this is, again, a very interesting way to look at how we are dealing with things. I think people forget that most LLMs out there are very general purpose, right? They were trained on enormous amount of internet data, which means when you actually apply these general purpose models to a specific scenario, they fail. Like I've consulted this one company which worked on marine industry, and they were trying to slap GPT-4 API to help them, generate responses or write emails. They had a very specific use case for writing emails. But that's when I realized, like, you really can't use GPT-4 API because it won't understand a lot of terminologies that are very, very specific to marine industry, right? And that's where a lot of teams go wrong as well. You look at this model, which is ever so knowing and obviously has like a lot of data that it has learned from, and you're like, yeah, now it will answer every question that the customer puts out as in the customer support, right? But that's not necessarily true. It might actually not know the domain that you're going after. So this particular scenario is also like that. What would you do if you were in this place, right? Would you use like a single powerful model like GPT for all tasks to sort of simplify integration and maintenance? Would you build separate applications for each task type with different applications? Or would you create like an abstraction layer that allows you to use different AI models optimized for each specific task? Or would you outsource each AI capability to third-party vendors? And I know like I already gave like the answer out for this, but great to see people are using other responses. This means you folks are still awake. So that's a win. So yeah, I would say like, yeah, actually creating an abstraction layer works the best. And also the fact that you can actually route to different LLM models. So right now, there's a new concept called judges and routers. I don't know how much you are familiar with it. It's relatively new, but what it does is it asks like a model to sit in between and actually evaluate whether your prompt that you send to this model should be sent to a smaller model that could perhaps like answer a simple question like, what's the capital of France? You don't need to probably prompt a big LLM like GPT-4, right? You could get away with prompting a small LLM as well. And that's what happens here is that when you create this abstraction layer, you're trying to get to different models that are specialized to do certain tasks. For example, I don't know if you've realized, like Claude actually generates better coding. Like it's great for vibe coding, at least for me, as compared to GPT-4. And there's certain studies that actually show that as well. So let us say a customer is asking something very specific to the code, or you get like a question which is very specific to a code. It makes more sense to send it to a model like Claude because it can actually understand code better than, let us say, Llama 7B, right? And the small abstraction that you actually end up creating will make sure that your application is much more sustainable in the long run. Because these general purpose models will keep continuing to be general purpose, but that doesn't mean it is perfect for everything you're looking out there. I'm going to move ahead because I know I've asked a lot of questions already and get to the most important part, which is like, which kind of open source libraries that I think are under threat from AI or what is happening around us, with especially vibe coding and sort of prompting GPTs, right? And so let us say this question, right? Which category or like which type of open source library do you think has a higher chance of being replaced by LLMs? So again, like a very easy question out there and no right or wrong answers. It's a very opinionated talk, so feel free to disagree with me at any point and go like, no, I don't think it's going to happen. It's completely fine too. Yeah. So yeah, so I think a lot of people got the right answer. According to me, I do think it's a lot of interface and convenience libraries. Like, for example, there's a library that I'll talk about, but there's a library that helps you create slugs out of your text, right? It's called Slugify. It's a Python library. So what happens is you could just create the slug by prompting GPT, right? You could send it to GPT and be like, hey, GPT, can you actually create like a slug out of it? And most teams are now doing that. They aren't going and searching Stack Overflow anymore to figure out the best Python library out there. They're already prompting GPT, right? And which I think is not great, and for several reasons, but that is definitely happening already. So this is one library, as I talked about. So if you see here on the code on your left-hand side, that's what is required to actually turn the text into slug. But you see on the one on the right, that is what is needed to actually convert it using GPT-4. You have to write a whole prompt to ask it to take care of every edge case and also like create a slug out of it, right? So this is happening already. And that is why I believe a lot of these Python libraries are vulnerable to LLM replacement. For example, string manipulation library, data formatting libraries, and simple web API and like web and API utilities. So something as simple as tabulate, humanize, making number, dates, and file size more readable. Or over here, I also had this emoji, converting emoji codes and Unicode representations. And I don't think we realize the Python ecosystem is so large, and it's been held by a lot of open source developers that worked really hard to build a lot of these, right? some of them might be directly used by LLMs as well. Like, for example, if you ask an LLM to generate a plot, right, or a graph, it will use matplotlib, which is good, right? But at the same time, we know for a fact that it's using these Python libraries sometimes, but mostly it isn't. And the space where it's actually not using Python libraries has the highest chance to hallucinate, right? So you put it out for production, and there's a good chance, because you just prompted it, you never knew the edge cases. And it ended up missing it. But you have to realize when you actually use these Python libraries, they have been built for a lot of years thinking about those edge cases in mind. So yeah, I will go ahead because I don't want to bore you with too many questions. But yeah, so I actually generated this very quick website. You can also scan it over here if you want to check it out. Okay. So the idea behind this website and why I put it out there is because let us say you were using Slugify instead of, or let us say you were using GPT to prompt and remove the slug, right? Or generate the slug from your text, right? What happens is when you put it into production, there's going to be a million tokens that's going to take over time, right? As your users increase. So this means there's going to be cost for using GPT-4o, which we don't realize right now because everyone is like, oh, these models are very cheap. But I've also done good analysis, and I'll show that later. But there's actual proof that there's a race to the bottom with how cheap these models are. So wouldn't it make sense to actually use a Python library instead, which is free of cost? So this is almost like an ironic calculator I created. But the idea behind it is if you were to use talk about the libraries, and you were talking about amount of tokens per. Oh, yeah, and let us say you were also giving average tokens per second and the AI model, you could calculate the risk cost. So the idea behind it is, as the number of tokens keep increasing. This means every time a user is asking something, you are actually pinging GPT-4. You're pinging a lot of different models to get your answer, right? So over time, this graph is almost exponential. It keeps increasing for you because the cost will keep increasing because you actually used prompts instead of using the Python libraries directly. So this is what this basically goes through, and it's just a way for people to realize that, yeah, you really cannot use GPT-4o or prompt these models. And happy to have you take a look and see if there are ways to improve it. Yeah. So I really think there's a huge reason why we need to preserve open source in the ecosystem or in the age of AI. Because right now, a lot of new developers and new software engineers are probably not thinking about these open source libraries at all, which were probably maintained and built by really, people who wanted to give back to the community, right? And I think there's a bigger need to start preserving these libraries and sort of raising the point that, oh yeah, please don't stop doing prompt and pray, right? And I also put up these, and if you look at ways to sort of understand, okay, now I still want to build Python libraries, right? But how do I end up doing that? I want to still build Python libraries in the age of AI. So for that, I actually put up this nice pipeline diagram that goes over the various parts of how machine learning models are built. Probably you already know that. And I think certain libraries that are wrapped around these AI pipelines will survive, right? So for example, if you were looking at the data layer, you could be using something like a vector database layer, like for example, PyCon or Llama Index or LangChain for orchestration. So that I think will still survive because that is around AI pipelines, right? And the same for prompt layers, right? So I am gonna shamelessly plug here, but I actually have been working on a open source libraries that helps people understand how to prompt better because a lot of people are very verbose with the way and they use please and thank yous to model, which they don't need to. And I said, okay, fine, is there a way to actually reduce tokens? So I actually generated a Python library that is sort of wrapped around or just works on the prompt layer. And then obviously for monitoring layer as well, I don't know if you already know that, there are like a lot of ways to evaluate models. There's LangFuse, there's Ragas. These Python libraries are again very sustainable because they're helping you evaluate prompts. They're helping you make sure that these pipelines survive over time. So yeah, I have another question here, and sorry for that again. It's a way to just get your attention here. So yeah, so let us say it's a health co-op which sort of got hit by a regulatory audit, and the AI diagnostic system gave wrong cancer screening results to more than 200 plus patients. I mean, it can still happen. And the FDA is investigating, and insurance won't cover claims, and they are facing close to 2 million in lawsuit, right? And let us say there's an emergency board meeting, and they say, oh, we need to fix this, or we are bankrupt. So which tools do you really think they will need to absolutely fix something like this? Will they need like requests, like API calls to patient database? Would they need Ragas that helps you sort of evaluate LLM responses and reduces hallucination? Will they help you, will it help to ping matplotlib or JSON, right? And this is a pretty straightforward answer out here. But the idea and the hope that I have from a question like this is the fact that, again, like AI libraries or like Python libraries can still be built around AI pipelines, which will still be very useful and still will be maintained by a huge number of people. And I think that is another way to survive what is happening and what is coming forward, is to adapt these libraries and make sure they are fixated somewhere in the AI pipeline. Yeah, so awesome. So you already figured out its answer B, which is Ragas, which helps you sort of evaluate LLM responses and reduce hallucination. So yeah, and another thing that I would say, and again, the talk here is purely like, it's not a product talk, it's not a talk to, advertise something. I'm doing this talk to sort of put out there that it's important to do open source work, and it's important to have like the symbiotic relationship even in the age of AI, right? And that is what my hope is here with preserving it. And I've also put up an open source learning hub. You can also submit your own open source, courses or anything else that really helps people understand the value of open source, and this can be found in the QR code there. Other ways that I think organizations can, what can they really do to make sure that if they support open source work, is like you can conduct like a OSS inventory, sort of identify which open source components are critical for your infrastructure, establish contribution guidelines, and allocate support resources. We still need organizations to really support open source work, which is going to decline, so we need more people to sort of advocate for it. And yeah, so again, like open source ecosystem represents decades of collaborative human knowledge that benefits all of software development, which is, again, very important to wherever we are going next. And I think like the most successful organizations will recognize that it's just not about altruism. It's about ensuring that the foundation upon which all the software innovation still depends on like this, strong and vibrant future generations of developers, right? Even though they might say that, yeah, like, LLMs will replace developers, or we have like a possibility, or like even like, executives on top might think that, I still do believe that there's a space where both can coexist, and most importantly, open source can still survive. Okay, awesome. I will move ahead. And yeah, I think like, this actually is a good question. Okay, so this question is very interesting because I talk about this pricing paradox, right? What happens is, let us say your startup was sort of built on a product with an AI agent, and there's a cost of around like $20 a month, right? That's what you see when you prompt GPT-4o. You're like, so cheap per token. Why can't I just use this, right? And the AI agent sort of handles customer support, generates content, and monitors your system. 6 months later, you receive an email. Due to increased operational costs, our pricing will change to $200 per month. FYI, Claude just did that. So, and there's usage-based pricing starting next month, right? So what fundamental risk do you think such a scenario illustrates about AI-first architecture? Is it A, risk of AI models becoming outdated too quickly? Is it B, the dependency of subsidized AI services that will eventually need to change sustainable pricing? Is it C, the challenge of training employees to use AI tools effectively? Or is it D, keeping up with the rapidly changing AI technology? And again, the answers, there doesn't need to be right or wrong, which I think a lot of people already got. So yeah, exactly. So I think like there is a bit of a pricing paradox. And I think like Gurgly again has a great tweet around it. But what we need to realize is right now a lot of tools are subsidized. Like I have been an AI engineer for quite some time, and I know like pre-GPT, when we trained models from scratch, when we trained them for like particular use cases like deep neural networks, it actually costed a lot, right? And the fact that they are giving you such large language models for $20 a month means that there is a catch, right? And I think like we are sort of ignoring that right now and going ahead and creating a lot of application that are dependent on this, but eventually we will start to see the cracks. And yeah, so firstly, like a lot of things, a lot of companies that I talk to, they often go like, yeah, our architecture is already dependent on GPT-4 Mini, right? We can't change it right now. So that's another thing that will happen eventually, is that people will start building all of their technologies around LLMs, right? And architectural dependencies are sticky, because once you build it, there's little to no change that you'll actually do in the whole pipeline. And integration complexity compounds. That's another thing. So token cost is always an exponential cost, right? As your users increase, the amount of tokens you put is actually exponential. So let us say you were talking to an LLM or a GPT, right? When you start the conversation, it might start with one question. But every time you ask it the next question, it's basically taking all the chats that you talked to it previously into the model as well, right? And it's having that context. So what does context mean here? It's a multiplication factor of your tokens. And in some ways, your feature dependency creates a lock-in. Applications are built around provider-specific capabilities, and you may not have equivalent alternatives. So yeah, this is like towards the end. I also have a library rescue network here that I quickly vibe coded. And the idea behind this is that you can actually like submit, you can submit any Python library that you think is under risk, and I'll try to promote it and put it up on the website, and we can hopefully get more people involved, and they can possibly help out with making sure that such libraries sustain, but most importantly, if they can be used in some parts of the AI pipeline, maybe that's a way to sustain it, and we elevate this problem that is happening. Yeah, that's pretty much it. I know I have only 5 to 10 minutes remaining, so I'll go ahead and ask folks for questions. And feel free to ask me any questions. I guess in PyLadies Berlin, they have like this rule of no stupid questions. Like no question is stupid enough to not be asked. So please go ahead and ask me questions. Yeah.
Thank you very much. So the questions, please ask them on Slido. I'm checking now.
You can also raise your hands and ask. We are a small group.
Yes,
so
if you want, we are not so many, so we can also ask directly.
Yeah, go ahead.
Sorry.
Thank you for an amazing presentation. My question is, as an ML engineer, where would you encourage me to invest my learning and skill focuses?
Yeah, that's a good question. I think there has to be a balance in which we sort of learn and understand machine learning models. And I think a lot of how we learn machine learning models has to still come from traditional learning instead of just learning how LLMs were put together or how tokenizers were built. I think the learning has to still be very rudimentary. And when you do rudimentary learning, you're in any way, you will learn important parts of the Python libraries used to create that, right? Instead of learning just about LLMs. And I think the learning definitely has to change for that. But yeah, great question. Thank you so much, Jessica. Yeah.
Okay, other questions?
It's okay.
I see no one on Slido.
Yes, yeah.
Sorry.
So, don't you think that with LLMs getting commoditized, the price is going to go down, actually, not up, as you said in your last slide?
Yeah, I think the prices right now are heavily subsidized, right? They're trying to compete with each other on the prices. But if you notice, like, better models are still priced much more than models that are way smaller, right? And let us say you were trying to build like a whole infrastructure around these models, right? Or like trying to build an application. In the end, you would want to use the best model that's out there, right? So let us say it's O3 or it's like, you know, the latest Claude model. It will still be priced way higher than a GPT-4 Mini, right? And that itself will start showing up in your like wallet, right? And you won't realize it now, like once you deploy like a MVP, but once you put it out there and you want like thousands of people or 100,000 people to actually ping it, the costs slowly rise, right? And we know for a fact, like there's another like discussion that I was having recently, like a lot of these chips that are made, right? Like we know there's Moore's law that states that, okay, you know, chips will keep reducing every time like 2x in the size, right? And that means like you can fit more AI models in the chips, like at least on paper. But we know for a fact that even if chips reduce size every year, your models are still getting way bigger at a much more bigger rate than the chips are getting smaller. So eventually we will come to this point where, you know, it might seem it's subsidized for now, but like let us take Uber or something, right? The way that Uber did is like they monopolized the market and then they increased the prices. And I think that's what these companies are doing right now, especially big LLM providers. They're just trying to reach market sizes. Yeah.
Okay, thank you. Other questions? So I have one,
Yeah, sure.
which is, so I think this points out how much is important to have open source models and open weight models.
Yeah.
So I think it's also important to have community efforts to build models that can be
Yes,
used.
absolutely. And I think like modeling itself is just not a single API call, which I think a lot of people forget, is that models are really built to do specific tasks. They are not built to be general purpose. And the more we try to build like and try making these models all knowing, the more we're going to see places where it fails. So I think it's very important that we actually think about much more community effort building, testing, and understanding these models. And that can only happen if we, you know, push for the fact that there shouldn't be closed source models in the first place. And if they're open source models, we're testing them for the right situations, and they just don't come out and go like, oh, wow, our model cleared like a law exam, right? They cleared a law exam, but we also know for a fact that the law exam could have been in the training data, right? So those discrepancies won't come out until we do the testing and until we push for it. And I think the community sort of forgets that it's a bigger force as well. Yeah. But yeah, thank you so much.
Anything else? Okay.
Yeah.
We have time, so.
I will ask her questions all day. I think so. I guess what I was thinking about is, like, you mentioned about new developers being less aware maybe of open source, and I think that's a very valid point. So I'm wondering, like, how we also engage people back into open source, considering I think we went through a period also where open source became trendy, but also part of big companies.
Yeah.
What's your thoughts there?
Yeah, that's a really good question. I think like companies again play a huge role in making sure open source actually stays alive. So this means like if you're part of an engineering team, you can actually advocate for more open source tooling, and you can be like, yeah, we can use GPT-4o and it looks like an easy solution today, but it's not an easy solution in the long term. So I think like there will be people who would have to advocate for change. That's exactly what happened with open source before, and why like Linux and stuff like survived in the age of whatever is happening. So yeah, it's a much more community concerted effort, and I think like it's important that engineers recognize that, which is why I'm doing these talks in the hope that I can push like even 5 people forward today. Yeah.
Okay. Anyone? We have 5 minutes.
It's okay. Yeah, I think everyone also needs to go for the coffee break, so we might as well leave early, yeah.
So I think
Yeah.
we're good. Thank you very much.
Thank you so much for attending.